Okay, everybody, thank you for joining us for the last day on our webinar series, introducing the Water Hub. And just like every other day, I'm going to begin today, as every other day, with respectfully honoring and acknowledging that I live and work in the traditional territories of the Tanaha, Secwepemc, Silks, and Sinixt peoples. Okay, and before I get started, I want to address a little bit about yesterday and some of the concerns that rose up through our feedback and how there was just a lot of information happening there. And I just wanted to reassure you that you don't need in-depth technical knowledge in order for you to be able to use our Water Hub and take full advantage of it and have your data with us and have us be there for you. And we're able to guide you through every single step one-on-one. And again, I encourage you to make those meetings with me using the Calendly link that we've been providing, and I can make that available to you again if needed. We are learning throughout this process, and we appreciate all the feedback as you've been giving us so that we can better serve you. We want the Water Hub to be the go-to for your data needs and are getting support from other places in order to increase our capacity to serve view groups within the basin. And so now we can get started. So far, we've had the tour of the Water Hub, and we've also seen how to search, download, format, and upload data. And so now it is time that we put CCAN's API on the spot. So this tool allows us to extract data, excuse me, allows us to extract data from the Water Hub and use it for different purposes. Today, I would like to display how I have brought in some GPS points that I made for myself and a little bit of a citizen science scenario for this time. So yesterday, I went out with Avenza Maps and I created a form so I could collect different parameters of water quality that I, as a citizen that lives right in the where Norns Creek and the Columbia River meet. This is where my house is. And so I get to see this creek every single day. So I was curious, what kind of parameters are there right now? And so we're gonna be using QGIS to make a very quick little map. And we're also gonna take a look at the data that we're gonna be working with today. So now I've just shared my screen so things that we can see. And I'm here in the Water Hub in our datasets page. So here is my Norns Creek Citizen Science Survey. So here I've got two different resources: monitoring station GPS points, which give us latitude, longitude, easting, and northing. So and it's within a within a UTM zone reference system. And so that is what we have. And then we also have our measurements. And so here in our measurements, you can see how it is all nicely, very nicely displayed. And we can see how well it's previewed. Here we have a variety of different things. So we have our ID, as we mentioned before and seen before, our units in a separate column. Then we have our bankful width. This is our flowing depth, or our flowing depth, the stagnation depth, both of our units, dissolved oxygen, a couple of parameters like temperature, and then we can actually download and look at this so we have a better idea, just because we're kind of cut off there. So we have the DO, the pH, temperature, turbidity, and the weather width, as well as slope. So I decided to look into most of the parameters that are taken during a cabin survey, just without the microinvertebrates, of course, because I don't have a kick net. Okay, so now that we kind of know what we're dealing with here, I'm interested to be able to grab this from QGIS, as I love QGIS and we have the ability to do so. So let's bring up QGIS, and I have already created a new project, and right now it's blank. And then just something to note is that my reference system is outlined right here with the WGS84 UTM Zone 11N, as we're here in Casigar. So that's already defined. So what I'm gonna do next is show you a really, really cool feature that, plugin that QGIS has. So QGIS has the ability for you to be able to look for plugins developed by other people. Most of them are also open source. And so here, what you have to do when you click, let's go back. You go to plugins right at the top here. We click there, manage and install plugins, and then we're going to go to all. And then here we can search, and all we have to do is type in CCAN, and then there's a CCAN browser plugin. Now we just install it. It's going to do its thing. It's done. Okay, so now we can just close. And then now this has created two little icons here. This is to launch the actual plugin, and this is to see the settings. So I want to define some settings first. The first field that we have is the cache directory. What this means is that when we download datasets straight from CCAN, they have to be saved somewhere temporarily. And so here, what I decided is that I have a specific drive for my files. And within my files, I have a GIS folder. And so within there, I pick that. And now I actually want to put it within the webinar. This is going to be my demonstration folder, working folder. And so now I just select that folder, and all of our data is going to be downloaded within there, and it's going to be very easily accessible from the browser view here on the left. Okay, the next thing we have to do is authentication. And because I've already done this before, you already see I have this basic here, but what I'm going to do is I'm going to delete it and say yes. So this is what you will see, no authentication. So in order to connect, we need to create a new one. And here, the name, we're going to call it Water Hub. This can be any name, really. And then the resource, an optional URL resource. So in order to find that, we're going to go back into our Water Hub. And then at the bottom, if you scroll all the way down, you can see the text that says, you can also access this registry using the API. Right there at the bottom. And so all you have to do is click on API, and it's going to give us this. If you've seen responses like this before, you know this is a JSON response. And so if we go to headers, it's going to give us more information about the server, the date, and more things that you kind of need to know web development about to know. But what we're really looking into is the host. So here we can grab this URL that's present right here, click copy, or right click and copy. Now we go back to QGIS, and our optional source goes right on there. Now, this is just a basic authentication. Our username is the same one that you use for the Water Hub. And so in my case, it is Santiago and 565605. And again, this is where, just a reminder, when you're creating your user, if you don't want to have to deal with those kind of weird numbers and lines and things like that, when you sign up, make sure to change it. And then here is a password. And then just type in your password just as you log in when you log into the Water Hub. And we just leave the realm empty. Now here, we just click save. And then that's ready. OK. And then now that's saved. OK, now all we have to do is click save. Now our settings are ready. Now we can go ahead and see if we can find the Water Hub. Now, here, this is the user interface that you would see. And I'm not sure, let's make this a little bit bigger so that maybe this will help see it better. I apologize, I can't really zoom into this view right here. But what we want to do is go to select CCAN servers right at the bottom there. So we select the CCAN servers, and this is where all the publicly available data for CCAN is. So this works way beyond just the Water Hub. It will work with any different database that you find, including the Skeena water database, Southern Skeena database, which also runs in CCAN, and DataBC runs in CCAN. You could find all this out. But right now, we're very mostly focused about the Water Hub, and I don't want to deviate from that. So this is what's called, in our first field, the CCAN API endpoint. Well, what does that mean? Let's go find out. So if we go back and we go to our data set of interest, and we go to the North Creek measurements, here we're going to have a green button that says Data API with all of our data sets. This is going to be very helpful when you're starting to develop and investigating the different capabilities of our API. So if we click on that, we're going to get this information, which first starts with the CCAN API and data store documentation. I really, really recommend you bookmark this so you can easily access, especially if you're a developer. It really allows you to do a lot of things, including uploading data sets. So if you're the kind of person who wants to make the automatic and automated uploads and edits to your data sets, that is possible, and we can find a way how we can set that up for you, making sure, of course, beforehand that all those data sets meet our quality standards before they go up there. And you really have to know about the metadata schema and all that to do it. So a word of advice, that's in another level of difficulty in order to do that. Okay, so back to our endpoints. Here, the first thing that we get is an endpoint. And so this is how we can access the API for the data store, meaning where our data is. So we can either create, update, and insert, query, or query via SQL. If we go further down and explore more, we can see some examples of querying for the first 5 results, for results containing joins, and using an SQL statement. You can also use JavaScript in order for you to call this, and then Python as well. We'll get a little bit more into that later. Endpoints. Okay, so what we want is click on this, and now that we know what it is, we'll go back to our data sets and we'll understand a little bit more. Go to our API, and now this URL at the top that takes you for the browser, that is our endpoint. We'll go back to QGIS, put in our endpoint, and making sure that it follows the format that's on there. So as you can see right now, it is missing a sideways thing. Then we're gonna test the connection to make sure that it worked, and it's gonna use our credentials. Fantastic, we got connection. We click OK, and then we're going to add CCAN server to the list. And then it's gonna ask us to name it. Well, this is the Water Hub. Now we've got the Water Hub. Okay, so now we just selected, make sure that it's clicked on there, click Save. And these are all of our categories that we have defined in CCAN before, that we know about them. So this means that everything worked. This is great. Now we're going to list all of the available data sets right here. Boom, all of our 4 data sets that are currently in there. And a little side note here, I deleted most, if not all, of the data sets because of our recent metadata changes. Some of them became corrupted. And that's why we were having some of the issues with the server connections when we're trying to do some things yesterday and the day before. And so now that it's a little bit more fixed, we can see that we're interested in the Norris Creek Citizen Survey. This is what we really want. And look at that. It gives us all of our metadata that we have present that I wrote on there, including the abstract, empty fields, and our citation and license. Okay, so now we are wondering about these 2, and we want them both. However, I want more information about it. So if I just click on this, it's even giving me the resource URL in case I want to just go straight to it and look at it in the database itself. But I want to download these directly. So now all I have to do is go down here, and with both of these resources selected, load data. And then we're going to get an error. Don't worry about this error because you have to go into QGIS and change a little bit of coding in order for it to be added onto all of our layers. It tried to do it, but there is no attribute that could be added as a vector layer. So it's because they're just CSVs, and for both. Okay, now, if we go back to where we set our cache to, or our temporary data, we can close that now. We said it was within a GIS, and I'm here on the browser right now, webinar, and then there's this weird number thing. Well, this weird number thing is actually the resource or the package ID of that data set, meaning the container of our resources has this specific ID, and this is how CCAN can identify it. Now, there are 2 down here with the same kind of weird alphanumeric identification. These are now the resource IDs, and these terms are going to come a little bit into play when we're looking into Python, so just keep those in mind. The data set ID or the package ID, and then the resource ID. Now let's open these up. So let's explore them first. We can open CSV externally. All right, so these are our GPS points. We got title of our points, stations, the date that they're created, latitude, longitude, northing, an easting, and a description. And I also did something that was very important here, which we're going to do later. It's a station ID. This is a numeric identification that we can use to create a join later on with our measurements. So let's just see how we can do that. Okay, so first I'm going to add my points. So in order to do that, I'm going to click layer. I'm going to go to add layer. And then if you scroll, the fourth one down is add a delimited text layer. Delimited meaning it's going to have a separation with different characters. So we know that this is a CSV, so a comma separated value right here. If you already know what you want to import, you could do it through here, but we don't have to do that right now. So now we can just go to scroll through these. These ones should all be okay, just as they are, unless, for example, if we remember some of the hobo, some of the hobo measurements that analysis that we looked at yesterday, they had a couple of rows before the actual measurement started. And so here we can specify how many header lines to discard. So if we figured out there was 4 rows before our data actually starts, we can fix that here. Now, this is the really other cool part. We already know that we have easting and northing, and we are within a UTM coordinate system. So our X field is going to be, oh, well, I guess I do have to pick the file. So we go back here and we find our resource will have the same name. And then it was the first one here, or GPS points, and select that. Okay, now we can get the fields for the geometry definition. Now, depending on what coordinate system you're using, this will change. For our X field, is going to be our easting, our Y field, our northing. This is the right coordinate system. And then we can see a little preview of the data. All we have to do now is click add. Okay, through that, close. We have our points. Fantastic. Now we just add our data, which I grabbed from up here. And it's a lot easier because we don't have to define how to display this data. And it's just giving us a normal CSV display. Here's our attribute data, our attribute table for this data, just as we saw in the CSV before. Now we can close that. And now we're going to go here into our GPS points, go to properties. And now I want to join all that data. So I'm going to go to joins, add a new join. And then the join layer is what do I want to join into this data set? And so here is the only CSV we have available. So that makes it really easy. And there's a good point for keeping all these databases and QGIS organized. It makes things like this a lot more easily, and naming is important there too. And then the join field. So what field in our table of values here are we using in order for us to be able to recognize and join both data sets? So we had mentioned that it was station ID. So we'll pick station ID. And then the target field is what field in our current table are we joining that to? Oh, look at that, station ID. It's like someone set it up or something. All right, so now we can just leave everything else as is. However, you can change some of the things here so you only join specific fields. That way you're not having repeats and stuff like that. And then something is the custom field name prefix. You can change so you know which table they came from, and then automatically you'll do that already. So now all we have to do is click OK. There's a layer done, apply. Now let's go see if this worked. Now would you look at that? At first, we have our first data set that goes to about here. And then we have our next data set starting about here. And it does have some weird names in the fields because it's first saying that it's coming from the water quality Norris Creek data set, and then it tells you what it is. So that's a little bit weird, and it would take some simple formatting to do. And again, this is not a tutorial on how to use QGIS, but rather a quick example as to how you can grab data like this, especially if you know what you're looking for. Okay, so that's putting that on there. And I would not be good if I didn't add a nice little background. And I downloaded this image. It's a TIFF file coming from the BC basemap store. And it's a 1 to 20,000 scale. And I'm going to control the layer rendering here so that we can actually see our points. And they're showing there already, so it's perfect. You can just make them a little bigger. like a 7. Let's apply it. And now I can see that our points are on a map, and it took me 15 minutes. Very easy, very straightforward, and easy to use. And just by the way, this is my house right here. So I'm right here, and it's super nice. I love seeing the mountains. We have an eagle nest around here. But anyways, I'm getting sidetracked now. Okay, so now obviously this map is not done. I would definitely go over my cartographic knowledge in terms of making sure that the colors are properly used. So like here are the grays and the grays, or maybe you want to use an SVG file for some more specific symbology. You want to add a title, you want to add um, a scale bar and all the different things. And that is something that we're also going to provide support with, is with the ability to show you how to do all of this and how to create beautiful products with the data that we're able to acquire together and setting all that up. Okay, so before I move out of QGIS, I just wanted to bring up that if you would like even more training beyond maybe what we can provide in the Water Hub too, is contact Richard Johnson. He specializes in QGIS. And so if you have any questions, yeah, reach out to him. And he's pretty awesome. So, all right. Now we can move on to the code. And a word of advice, please. This is, again, just a very, very big overview. I'm going to talk about some terms that might just like go right over your head, but all I'm trying to show is how, with a somewhat limited amount of knowledge of coding, you're able to access vast amounts of data. Okay. And also we can see how we can do this together, and you can learn with us. Now, this is a lot. So welcome to VSC code. VSC code is what I use in order to edit and run my code. There are various options for you to run your code, and these are called shells. So this is a place for you to be able to run it, basically. And some other notes when it comes to that is that you're going to require a specific set of packages, they're called. And in order to install those packages, you have to go through the command line and import them using pip. That's what I use. And another word on that is that, as you can see here, there's something that I kind of like doing, is describing what I do with my script. So everything that you see in green is commented out, meaning that it's not actually running that, it's just descriptions of things. And so when it was created, what Python version I'm running right now. So I'm running on the latest version of Python, 3.91. And this is the package that I have downloaded using pip. And one last thing before we begin here is the idea around environments. And so it is good practice for you to have an environment for different projects, because you may have to use different versions of Python depending on what you're doing. And so if you know what I'm talking about, you know what I'm talking about. And if not, let's talk more if you want to learn. And if not, yeah, just bear with us while we talk code. Okay, so let's start off. Now I want to see and use what is called an HTTP request. What this does is that using something called requests, which comes from the URL lib library, I can write import the package requests. And then I can even go a step forward if I really wanted to and say from URL lib, but that is not always necessary. Another thing we're going to need is JSON. And so this is just calling the JSON module within Python, making sure that it knows that we're using it. Okay, so I already have all the code set up, so you don't have to sit here seeing me do all the coding. And so all I have to do is uncomment some lines. So a quick note on Python: to comment things out, you just do a number sign, and it's usable and not usable. So it's great. Okay, so first, I have to define a variable or a container to get that HTTP response, and then see if we can have access. So we are looking to get a code of 200. There are a variety of different codes that you could get, and I'm sure you've seen them in your browser. When you go somewhere that doesn't exist, for example, you get a 404 code. That is not found, server not found. It doesn't exist. There's also 403, I believe, and that's restricted access, meaning you should not be here, and so on. If you would like to know more about those codes, I can send you some resources, or Google is also your best friend when you code. All right, so once we get that done, I want to print that response. So I want to print what I called data. We are looking for data. So data is going to equal requests, which we call back here, and then requests has the ability to get. To get means to go and get this URL. You are basically, imagine you're putting a web direction into your browser window. So now that we're getting this, I don't know if some of you might remember what this is, but this is our API endpoint. So here's where we can see if this works. So I'm going to select this, I'm going to right click it, and I'm going to run it in my Python terminal. Awesome, would you look at that? Right down here, if you can see it, right down here, we print data, response 200. And here, let me just, maybe that works better. Oops. Okay, so here we can see that we got the response that we wanted. This is fantastic. That means we have access to the endpoint. Fantastic. So now I'm going to just comment this out because we're done with that. Because now what we want to do is, now that I've received the success code, we're able to now ask for a JSON response of that so that we can have a better idea of what we have for our data sets. We need to add an action to our API now. So we basically have to tell it what to do. So now I'm going to uncomment these 2 lines here. I don't remember the shortcut for the keyboard to uncomment, but I remember to comment. Okay, so now we have the exact same container, right? So we have data, which is what we're looking for, and then the same requests, and then the same get. Now, the only thing that's changed is that after here, after the 3 that we had up here, we have now added what is called action. In the data store, which is what holds our data in CCAN, there's a variety of logics that then you're able to apply to this action. Right now, what I'm curious about is what data sets do we have in the Water Hub? So I'm going to do a package search. And I wanted to give it to me in a JSON format. Because if we don't specify this, it's going to give us the same 200 response that we just got now. And that's not necessarily what we want. Although you could do it to ensure that you're actually connected and getting the right response. So now we have that. I'm going to right click, and I'm going to run it in my Python terminal. And I crashed. So let's just kill this terminal here, close that, and then do it one more time. Welcome to the world of coding. Run it, and we've got success. Now we're kind of zoomed in, and there's a lot of data. So give me a second, I'll explain to you what this all means, because it is very overwhelming if you've never seen a response in a JSON format. You kind of need to know what you're looking at when you see this. So here's a few things. Here's the help, and this is the response that we get. The print data gave us everything below that I just scrolled above or past. So first, it's giving us a dictionary. And so Python has a variety of different file formats or arrays. And so there are different, there are tuples, which are just a list of things. There are lists, and then there's also what you call the dictionaries that I keep mentioning. So those dictionaries are interesting because there's also nested dictionaries. So they're dictionaries of dictionaries, and those dictionaries have keys. And so that's what we're looking for right now is keys so that we can access this data. And so it starts here, and the first thing we see is help. This is our first key, and we'll see how we can know this a little bit later. And then if we follow this link here, we can have a little more information about what happened here. But if you don't have the really knowledge, this even went over my head. Then we have the success. So this is telling us that the success is true. We received something, especially for the action. And now our result. And so here we have a count. That is how many data sets are there. And if you're paying attention for QGIS, you notice there are 4 data sets. And so it told us, sure enough, there are 4 data sets. That makes me really happy. Okay, so then it's telling us how it sorted everything. It sorted it, scoring descending when the when the last metadata modification happened in a descending manner. There was no facets, meaning other kind of actions that we were given this, because you can combine this with other actions as well if you're looking for packet search and a name and an ID, so find exactly what we're looking for. And then we have results. And this is the interesting part, as this has a huge dictionary of all the metadata of all of our packages and all of the resources. Meaning that when we have thousands of data sets within our Water Hub, I would be careful with just the package search action because might be sitting there watching your code run for a while. Okay, so now that we have that looked over, let me comment this out. And now I want to search for the package with the term Norns because it's from Norns Creek in it. So I already wrote that. All I have to do is uncomment it. And it's the exact same get question, or I mean action that we've required before. So it's very just copy and paste. So data, as you can see, is equals to our requests. And then we're asking requests to get this URL. There's our API, our action, and our same package search action from before. However, there is one difference. We have put the question mark, meaning there is something more to that. Q, as in a qualifying term for you to be able to search, and then the term itself. And here we put norms, this is what I'm looking for. And again, we're looking at that JSON response. And I want to print that data so that I can see what I'm looking at. So now let's select it. Hopefully we don't crash again. We're running our terminal and we crashed. Nice. Okay. So here we go. We go back to where we printed, which is right here, what we just ran. Right here. We see the same help response that we got from before. Success true. And then our result count 1 because there's only one data set with norms in its name. That's great. Same kind of sorting that happened from before. No extra facets. And then our results. And within our results, we see again all of the metadata, like our license title, who maintains it, the version, data disclosures, like I did. And so here, then you have all that I wrote for the disclosures of the data, excuse me. The citation, there's my name, who surveyed it, where it is, and something that I am the most interested in, however, is that if I wanted a resource out of here, super quickly, I can find the URL that says download, like this one, for the resource. And as you remember, I was telling you about before, the resource ID as we had seen them. So we've seen that number before. So I'm curious, what is this? I'm gonna control click, and it's gonna warn me because this is not always good practice when you receive codes from others to open links that are in the response. This can be dangerous when it's not within our Water Hub. So be mindful of opening links with code because it can be messy and virusy. So we're gonna open that because I trust it. And it's gonna ask me if I want to open or save this file because it's Windows Edge and it's all weird. I don't never use it, it's standard still. And look at that, it's our GPS points. Fantastic, so we were able to access that just with a little bit of code. Now, since we found that, what we want to do now, well, first I'm gonna comment this so that it doesn't run. Now that we found the resource ID of the file that we want, which is right here, and we're looking for the GPS points, let's say, oh, actually, let's go find our measurements. So our measurements were after our monitoring station GPS points. And so here they are with their name. So all we have to do is go find the next name on the list, and that will know is going to be the next resource. All right, so we're getting close. And so a lot of this is just very carefully reading through all these different arrays and commas and trying to pick out the different what are now keys or values for us to be able to call these. And that just comes with practice. and kind of knowing what you're doing. And again, we can sit together, and I would love to sit with every one of you, and we can see how this can benefit your organization. And so here I found my resource ID that I was interested in, which is right after the resource in the URL. So I can just go here, and I'm going to copy that. And another very easy way that you could do that is that you could go back to the Water Hub, go back to Norns Creek, and then we're going to preview our measurements. And then already here, we can see numbers that look kind of familiar to us, right? Here and on top of our web browser, this ID is everywhere. And so if you know what it is and where it is, you'll be able to very easily grab it. And so if we click on the Data API button that we saw before, now that we're looking more into querying, we can see here that it gives us examples exactly with the ID that it's doing and everything. So you can really play around and get to know this inside and out if you're a developer that enjoys playing with code. Okay, so now let's see if we can find that resource ID. So for sure, here it is. Resource ID is equal to this. Okay, so I'm gonna copy that. And then it ends on 20369. Let's see if it matches what we had done here. 20369. Fantastic. Okay, so now that I've done that, I already did it before. So I'm gonna uncomment these lines. Oops, this one is supposed to stay commented. Now we have our data for our container there. And I'm sorry if it's really hard to see. VS Studio doesn't really play too well. So our data, and we also want to print our data. So here, we're gonna run this. As you saw, I have already our resource ID put in here. And one thing that changed that I just forgot to mention is that our action has changed now. And so as you can see, before we had package search, we're looking for data sets. Now we're looking what's in the data store specifically. The question mark to separate the action. And we're specifying resource ID is going to equal what we found. And then also again, let's not forget that we want it in a JSON format so that we can really read it. Now I'm going to run this. And we'll probably crash again. I'm not really sure why it keeps doing that, but awesome. It did not crash on us this time. We can just keep going up and find where we printed. Okay, here, we printed data. Again, same thing. And you can really see how this is such a systematic process that you can take because you keep getting the same kind of responses. We have the help where you can go and see how everything happened online. Did it succeed? Yes, it's true, it succeeded. And all of results. What would you look at that? Now we have units, we have pH, we have turbidity, we have everything that we're seeing before. Now, how can I actually access that though? That's the big question because it is quite unusable in the way that it's looking at right now. So let's go see how we can do that. So I want to find what is the key for the dictionary. And I keep saying that. And so now we can maybe have better understanding of what this looks like. So here in this dictionary, this is the beginning. If you're looking at the terminal down here, this is the beginning. And then you can see help and then 2 points and then something and then a comma. Help is the first key. Comma separates the values. Then success being the next and so on. And then what you can see though is that result is a key. However, its value after the colon is all of it that's before. So if you look at this, you could try and devise what kind of keys you're looking at and how to read it. However, we can get the code to do that because it can get very annoying. So data, and then I'm gonna say that because we're talking about that data. Keys. I'm not gonna call that function. And then I'm gonna run this once more. And then we're gonna see what happens. Look at that. So print data keys has given us help, as I said, success, and our result. We're interested in the result. Let's go see what that looks like. All right. So I'm gonna comment this out as we don't need it. And actually, sorry, let's uncomment that and use this one still. Now, I'm gonna print the dictionary. And I know that result is what I want. So in order for you to call a key, I have to go with the square parentheses, single comma or thing in English. I kind of forget what those are called. And then I'm going to write result. So now what we're telling Python is that you're going to print data, but only what's within the result dictionary. So let's go see what that looks like. Print. And now, well, help is not there anymore. However, we do have our true, making sure that we know this is happening. Then our resource ID, like we said before, familiar, and then our fields. As you can see, this structure has changed a little bit now. And so if you wanted to then access these, you have to find their keys and so on. Then once all this is done, you could bring in NumPy or a variety of different packages like R packages or plotting. And then you can start figuring out how you can best slice this dictionary to get the values that we had before. So it's kind of hard to read here. And like I said, it can be difficult to wrap your hair around this kind of values, but we're able to get more things. And so maybe let's see if we can get something else. I'm curious about what the keys for results are. See if we can make it work. Keys. What do you give us? Running Python terminal. Look at that. So the keys for this dictionary are include total, resource ID, fields, records format, records, links, and total. And I know this from advanced. I want records. We're going to do the same thing now. Records. I'm going to run that. Right click, run a Python terminal. And now we have all of our records. The ID that Secan gave it, the title that I gave it when I was doing the collection, our station ID, our bankful width, our unit, and so on, and so on, and so on. And so with that, I want to close this off and just say that there is plenty of opportunity here for very fast analysis, modeling, and use of a variety of coding languages and platforms for GIS that make this very, very useful. And I am, like I keep saying, very excited to be able to try all of this with all of you and see how this is going to serve every single one of us. And so with that, as we usually do, I would love to go into the Q&A. I'm sure there's a few. And yeah, after the Q&A, we'll do the surveys as we usually do. And after that, we'll conclude our webinar series. Thank you, everybody, for giving me all your attention.
I have a question, Santiago. How do we access the recording of this? How and when?
Yeah, we're going to make this available through a YouTube link that we'll send out on Friday, and then these are also going to be posted on the website for the Water Hub under our help section. We're going to be having basically a library of tutorials as well as all of these webinars for reference. So yeah, you'll find this ones, and then in the future, we're going to make more tutorial videos on how to do coding and analysis, as well as we're going to be hosting the something called office hours. And so through the office hours, you'll be able to come in and drop in just the same way that a university office hours will work. And that way, if you have any really pressing questions or anything like that, we can all get together, and they're open to anyone that wants to join. And so they're a little bit different from the one-on-ones that I was talking about earlier. These are more like general questions where we can also come together and discuss data. Yeah, does that answer your question, Dennis?
Thanks very much.
Yeah, thank you. Adam, I like R. I just haven't had exposure to it. That's why I didn't present it here. I will start using it next semester during my spatial statistics class. But until then, I do recommend it. Again, it really depends on what you're comfortable in, what you enjoy writing with, and again, what you're proficient at, because it's kind of annoying having to use something that you haven't used before and figure out syntax and how everything works. So if you're comfortable in R or even JavaScript or SQL, however you're comfortable, the database is quite flexible when it comes to how you can access that. So like I said before, any HTTP get able language will be able to do that. And I'm pretty sure R has it, Python has it, JavaScript has it. most of the big ones do. So yeah.
So would you see that the Python would be something that you've been using currently then?
Yeah, yeah. So I run everything on Python and it works.
Sure.
So if
Okay.
that's where your area of expertise is, go for it. I'm going to be testing R and all the different languages to try and, I do enjoy app development and different API developments and seeing if I can create tools and stuff. So that's going to be me delving into that side and seeing how other languages play with this. Again, Python is what I'm comfortable in. It's what I've learned so far. So that's why I decided to do it this way. Um,
Sure. Okay. Thank you.
mhm. Yeah, Chad, thank you for that. And again, it does highlight the fact that it's a little bit of a lot for people that don't use scripting languages, and so that's why I wanted to show both sides, both the really simple QGIS grabbing data, as well as a little bit more complicated coding stuff. Um, and I do recommend maybe checking out DataCamp. So that's datacamp.com or edX, that's edx.com, or Coursera. So those are all free courses that you can access that have very high level intuitive stuff. And I learned to do small things on my phone with the apps that you kind of just drag and drop different different coding snippets. And I found that really helpful what I was learning. And just to take it simple, I really enjoy making really simple stuff with Python, like making it say hello world, just very simple stuff like that, and explore and have fun with it. I really think that that's the main point. That's the main point about it. While learning, of course, and also I can provide you some support with that, and I can show you some basic premises as to how to grab this data with Python and download it quickly, if that's what you're looking for. So yeah, we can discuss that during our meetings and one-on-one. So we're here for you and for everyone. So again, you do not need the extreme technical capabilities in order for you to use this. This webinar was just a big overview. Let's call it a skim of the surface. And chat, yeah, it would be. It would be just as you use ArcGIS. And it's the same premise. You just have to, I don't know the actual workflow at the top of my head, but it's just finding the same parameters that were before, right? Defining your username and your password and finding the API endpoint and finding where to put that within ArcGIS. I don't use it with Living Lakes. I use it with school and haven't been on S3's products in a quick minute because I really like open source stuff that works just as well. But I will look into it and get back to everyone, and that will be a good tutorial video for showing how to do this in different platforms. So thank you, Chat, for that. It's a great suggestion. So Chat said, somewhat off topic. All things being equal, would you recommend switching to QGIS with regards to functionality, ease of use, etc.? Oh, that's a hard question, Chad. Um, there's pros and cons to both, I think. I really think that it comes down to like capacity to be able to pay for Estrus products. Like you're kind of paying for stability and not having to maybe uh, play with a lot of things. However, I like and enjoy playing with things, and I think that QGIS has just as much ability as Esri to carry out some analysis and things. There's definitely some specialized toolboxes in ArcGIS that Q is maybe not quite there yet. I haven't explored them fully. Like for example, the hydrological toolboxes that Esri has. Um, so yeah, it really depends on what kind of level of analysis you're doing, what kind of stability you're looking for. You'll have a lot more support, let's say technical support from Esri's products compared to QGIS, even though QGIS is a huge community of contributors. Then there becomes a little bit more like personal opinion when you're looking for help with that sometimes. So yeah, it's such personal opinion when it comes to that, I think, and circumstantial that I would recommend them both, really. Like if you can buy ArcGIS, buy it. And if not, then save the money and use QGIS, but we're ready to be a little more technologically um, like savvy, I guess, maybe because of the plugins and whatnot.
Yeah, I find there's an incredible selection of the add-ons.
Yeah. I'd like to once again give every one of you a big thank you, and that I really appreciate all the attention and time that you've given us in the Water Hub. And yeah, it's a good reminder that we're here for you and want to make some data happen.